Our next speaker, Guilherme Diaz-Berrio, co-founder of Pine Marsh, will tackle the common pitfalls and misuse of GenAI, especially in data analytics for marketing. From hallucination to poorly executed proofs of concepts, Guilherme will guide us on how to use GenAI effectively and responsibly. Please, a warm welcome to Guilherme.
Ready. So the presentation is.
There.
So, hello. Good morning. Thanks for having me. This talk is going to be a little bit of a downer sometimes. When GenAI appeared 2 years ago, everyone started using it for pretty much everything. We thought basically that we could automate the role of an analyst or a data scientist using ChatGPT. Of course, hopefully now we know that is wrong. So I think the first question we need to answer when we're dealing with a GenAI project is, do we really need GenAI for that? And I have huge faith in GenAI, I have huge faith in AI, I'm a data scientist, I love AI, I love ML, but not everything needs to be a generative AI model. Sometimes you can get better results with other types of ML. And most often, you end up using a cannon to kill a mosquito. A common pet peeve of mine, and I've seen this multiple times, and usually it doesn't go well, is using LLMs and ChatGPT or Claude or any other model to do forecasting or regression. And autoregressive models and transformer models are not the best for this task. And there are multiple reasons. Discriminative AI, common linear regression, and other models are way faster, they're more accurate, and they are easy to train and deploy and maintain. A good example, for instance, is sales forecasting and digital marketing spend forecasting, where an ETS model or a simple ARIMA model will achieve you better results with less error. And the reason is an LLM isn't meant to be forecasting a time series, it's meant to be predicting the next token and the next word. And even if you go back a step and you try to do a time series foundation model in which you're using a transformer, again, you are over-engineering things. And a RIM or an ETS, in my personal experience over multiple clients and over my professional life, gets you the same or better results. And here's the thing, you don't need an H100 GPU to run them, you can run them on your laptop. A slightly different problem, and this is trickier, is classification problems. So LLMs are somewhat good at classification, at least the frontier models. Now, here's the thing. One, you can get better results with classic ML. B, it takes you considerable effort to fine-tune a large language model to do classification of specific things. So for instance, if you're doing a simple spam filter, there's no point in using a large language model to just do something you can do with a naive Bayes classifier. Again, you're overusing a model. And even for things like query understanding, i.e., having a model that understands that if I'm searching Amazon, am I searching the rainforest or am I searching the online retailer? LLMs are not the best model. BERT is the best model. In fact, BERTs were developed for that. They are the original transformer architecture. The Google paper comes from it. And for instance, for named entity resolution, i.e. understanding, for instance, the names of brands, BERT models and all of the evolutions, like the Roberta model, are way more efficient and they are smaller. The second question you should always ask, and I had a client I was working with where this was a major issue, is do you have the right data? Is it centralized? And is it modeled? So I had a customer I was working with. They had a very tricky setup. They had tag management with Tilium, they had Adobe Analytics, they were moving to Snowplow, they were in the gambling sector, so their tracking was incredibly custom-made, and they were working off of 3 different databases. So their first POC was to throw an LLM at Snowplow, ChatGPT, 3.5 turbo at the time. And of course, it failed miserably. And then the next step would be, oh, let's do RAG. But again, we don't have a semantic layer. We don't have the tables modeled. Nothing is standard. So having the right data, having the data cleaned and having the data modeled is really important. Everyone says it. Very few people in teams have the time to do it because there's a lot of technical debt usually on data teams, and it is cumbersome. And the little details matter, and this is a bit of a personal history and a bit of something that stumped me once. I was working with numbers and dates, and I was trying to get an LLM to generate SQL to get auto-generated reports of sales data and marketing spend. And of course, at the time, I already knew, okay, I need to give context to the LLM, what are the tables, fine, that's all fine and done. I need to teach it what Q1 is, because we understand what the first quarter is, and LLM might not. The fiscal quarter might be unaligned, which it was. The fourth quarter of this company is actually the first calendar quarter. And for the life of me, I couldn't get the LLM to understand dates. And we had users querying it, like usual chatbot, and they were putting November date or 21st of October or 21st/10 or 21st-10, and every single time I got a different result. Eventually, I realized that the problem is the tokenizer. And this is an interesting roadblock. So large language models do not understand words. They understand tokens. Now, we know that roughly a token is a word, but the roughly part is important. Sometimes it can break a word in half, or it can be a word in a space. For instance, capitalization changes. This is especially critical with dates. 21st/11/2025 is not tokenized the same way as 21st/November/2025 or dash, which means the large language model is going to understand those symbols differently. It's going to interpret those symbols differently. And if you change the language model, you change the tokenizer, because each language model has its own tokenizer. For instance, you can do this test on OpenAI, they use tick token, and you can do this test. So this is a little bit of a roadblock. A different problem is also numbers, and by the way, math. So we all seen the GSM-8K results or the math benchmarks where frontier models get 80% or 90%, ChatGPT 4.0, O1 Preview, 3.5 Sonnet. There's a new benchmark called Frontier Math. It's been done with the help of mathematician Terence Tao. It uses the same framework as ARC, i.e. a private data set that LLMs can't train on. And most LLMs, most frontier models can't solve 2% of the problems. So large language models are still bad at math. They are still bad at dealing with numbers. And in analytics, that's basically all we're doing. And we shouldn't have an LLM hallucinate sales numbers. And this is particularly tricky. And speaking of hallucinations, which is a very fancy way of saying I'm getting things wrong, they still hallucinate. This is dangerous in a business context. If you're auto-generating a report on sales data, you're trying to automate an analyst out, and you got wrong sales number. It just made up things. And to understand this is very simple, and this is architectural. A large language model is essentially predicting the next word. The next token is taking a sampling distribution and picking one out. And the temperature adjusts the way it samples. So the higher the temperature, the more you're sampling from the tails. So 90% of the times, you're sampling the right token, but there is a chance that you're going to be sampling the wrong token. And since LLMs are auto-regressive in nature, that token is going to be fed back in. The entire prompt is going to be reread, generate the next token and the next token, which means you are going to get stuck in a local minimum. We've all have, I'm assuming, the experience of dealing with Claude or ChatGPT and trying to program and getting it stuck on a local minimum. Even Cursor, I'm a huge fan of Cursor, and they do fine-tune some of their coding models. But even with Cursor, I got stuck the other day, because he couldn't get out of that local minimum. The tokens were generated in such a way that he got stuck, and I had to get to the 3 checkpoints above so he could forget what he was seeing and regenerate the token, and then I got it right. So this is something you need to deal. Now, the usual solution to this is RAG. And I also am a huge believer in RAG, but RAG isn't magical. In fact, the magical part is on the document retrieval part, not the generative AI part. And this is important because document retrieval and context and query composition is hard. In fact, it is called information retrieval. It is not a new field. It is not GenAI. It's what basically search engines are built for. Lucene, those type of search engines, which is why the transformer architecture came originally from Google. This is a search problem at its core. Now, this means that if you're doing RAG, sometimes you always, and I had a PoC at the company I work with, where you're tempted like, okay, I'm going to have an embedding database, I'm going to create the embeddings, I have a vector database, I'm going to go chunk the documents, throw it in there, and just answer things. And if you do a simple BM25 keyword search, which again, it's a 30-year-old algorithm, TF-IDF, keyword search, you get better results. In fact, standard RAG these days is usually done with a bi-encoder and a hybrid setup where on one hand you're taking the embeddings, and on the other hand you're taking BM25 keyword search, and then you're merging them and rearranging the query. So keep it simple is one of the main takeaways. The second is not everything needs a vector database. Pinecone, wherever. You can get a lot of mileage from just using Postgres. In fact, Postgres does vector search, and the SQL standards is going to have vector types. So from 2025 onward, there's going to be databases that are going to implement. And I feel, this is personal opinion of mine, I feel that the entire vector DB space is similar to the NoSQL space, where they started with, we don't like SQL, we don't like the entire relational model. Now NoSQL means not only SQL, they are now converts. I think vector DBs are going to be the same. If you want to use a vector DB, use LanceDB. It's incredibly small, incredibly powerful. But again, information retrieval is your friend, and there's a lot of research done here. Evals. I should have started with this, but evaluate, and not as an afterthought. Start evaluating at the beginning. You need to evaluate everything. You need to evaluate the quality of the data, but also the quality of the model. And evals implies logging also. So log your prompts, log your responses, log from which model it came from, because we all know that Llama 3.2, Sonnet, ChatGPT, GPT-4o, GPT-4, o1, you're going to have different performances, even if you keep the same prompt with different models. The quality of the prompt, this goes without saying, and the quality of the retrieval. And when thinking evaluation, and again, data scientists, we know this, so let's not forget what we were trained on. We know how to evaluate things. With GenAI, that's not different. In fact, it's more important because we don't have deterministic results. So start with simple unit tests. I should have expectations of what the data should look like. And if I don't know, then I need to contact a domain expert on it. If I'm classifying addresses, or I had this exercise where I was trying to clean up a huge CSV of companies. It was incredibly dirty, and it was 1,800 lines worth. And I have an expectation of what an address looks like. I have an expectation of what a phone number looks like. So unit tests. Then simple metrics like accuracy and precision and recall, especially if you're doing RAG, and most often than not, you are doing RAG. So this simple metrics can go a long way in helping you ascertain what's wrong. I wrote a book on data analytics for marketing. This is not a plug. This is just to explain that I was playing with RAG the other day, trying to generate content based on my book. And I was playing with LansDB and Cohere, the re-ranker, and some fancy things. And I benchmarked it against BM25, and lo and behold, BM25 was outperforming. So instead of using embeddings, keyword research was good enough. Having those metrics is important. And then you move on to model and human evals. And this is where you have a domain expert checking are the outputs correct, and then you eventually evolve into LLM as a judge, which is tricky because then you need to use a high-powered large language model to judge the lower model. You might need to fine-tune it. You can get down the rabbit hole really fast. So you need clear metrics. You also need to be aware of what's being called evaluation drift, which is expectations of who's evaluating change. So we all had this experience of ChatGPT 3. We were wowed. Now we go back to it, and it seems dumb to us, because we are expecting now 3.5 Sonnet level performance or 4.0 level performance. So our standard of is it good or bad changes, and you need to account for that. Also, this is personal taste and experience. Make your evaluations as binary as possible. I've seen clients do the following. They're doing a classification problem, and then they have a dashboard with numbers from 1 to 5. That is incredibly subjective. It's either good or bad. It makes your life way easier. And on the UI front, you can have a chatbot, for instance, and you can have a thumbs up or a thumbs down, and the user can say, yeah, I don't like this. It makes your life easier. So make them binary if possible. And always remember, what are you trying to achieve? You need to understand what the metric is. You need to understand what's your end goal. If I'm doing an automated copy creator for ads based on a digital feed, then my accuracy requirements are not that large. If I'm doing an automated report, or I'm trying to, then it's going to be different if I am hallucinating numbers to the CEO. And this might be controversial. I think it's not as controversial as it was a while back ago, but LLMs are autoregressive in nature, which means they, again, generate a token, feed it back into the transformer, and generate the next token, and so forth. They are good at generating text. They are incredibly good at generating text. They are good at memorizing. They are good at compressing information. They are not good at reasoning, not above demoware. Complex reasoning, they can't do it. Complex planning, they can't do it. What they're doing is they are memorizing huge plans. And if your activity is within 90% of what Stack Overflow writes, you're fine. The moment you sidetrack to a portion of the distribution that is not well sampled, you're going to be stuck. And good examples of this are the math problems, where we all know that the main frontier operators are training on benchmarks, even if they say they aren't, because you can extract the canary strings out of them. And the moment you hide and create problems that are private, the frontier models no longer are performing at 90% level, they're performing at 2 to 12%. AGI is a good benchmark. Frontier math is another good benchmark. So they're not reasoning. The usual approach around this is you're generating multiple outputs. That's chain of thought or tree of thought. You're basically generating multiple ideas, and then you're trying to sort through them. And personal experience, your mileage may vary. In production, this doesn't work that well. You're going to get stuck a lot of times. In fact, we all done that exercise of playing with baby AGI back in the past and getting it stuck on a non-trivial problem. Another thing to be careful, and I think 20 years research, this is going to be awesome. Careful with agents. It's an interesting approach. I would love it to work. They're not a silver bullet, and my pet peeve with them is the following. Even if you have a 90% accurate model, most of what happens in data analytics involves multiple steps of thought. You can easily go 6, 7 steps deep. If you have a process that's 90% accurate, after 7 steps of compounding, you're under 50% of accuracy. You wouldn't trust an analyst doing this. You would consider them really junior and train them. You would be supervising them. So I think this is the last mile, and I think this is akin to self-driving cars. Ever since 2010, everyone was like, oh, we're 90% there. We can drive around the block, and we've been spending the last 15 years getting to 90-something%, and we're going to spend the next 10 years getting to 98. So that last mile is important, and the problem is that last mile is incredibly important for agents. So this is something I've learned on a Google talk, and I kind of kept it, which is IVO, immediately validated outputs, which is personal opinion. You can't leave LLMs unsupervised. But if you can design a system in which you have an expert, and the expert can immediately validate what the LLM is doing, then it's helpful. Because then you can catch it in time, and you can validate it, and you can score it, and you can adjust it and fine-tune it, and this will help you catch errors. So this is why I don't believe that neither data scientists or analysts are out of work yet. I think this is augmenting us, but yeah. So in conclusion, I'm 23 minutes, so in conclusion, LLMs are not magic. They are just very good at generating text. They are great information compressors, although they are lossy. They are not good at reasoning. They can augment our capabilities. Sometimes you need AI, but most often you don't need GenAI. Always look at your data and basically focus on evals. If you take anything out of this, evals, please, and logging. And yeah, that's it.
All right, Guilherme. Questions?
Or not.
So far,
Very
people are afraid to get on a spot. All right, thank you very much, Guilherme. And a second. Thank you for this very interesting presentation. This is a token of appreciation. Thank you very much.